Welcome to part 7 of a series of videos showing how to create and use methods in OmniView. In the previous video, I mapped this answer to a digital Modbus program. Here's the answer value that I have mapped out to DCS device. We do also support another type of DCS system, which is by using an Opto22 snap panel. And so let's go take a look at my I/O devices. You can see that I have one defined. We actually have on our network an Opto panel sitting out in the engineering lab that has been configured to this IP address. How to set up the Opto22 device will be shown in another video. What we're going to do today is we're going to map another one of our methods that created earlier. So we're going to map this method to a position on the Opto22 panel. After I've selected the row down here, I'm still looking at the Modbus device here. I need to go select the Opto22 device here. Now notice for Opto22 it calls these addressing values by different names. The position is the actual physical slot number on the panel. So the number that shows up here depends on how you've input-output modules you have installed onto the Opto panel. So in slot 2 we have an analog output module installed on the Opto. So I will select that position, and each Opto analog output module can show two values. So we're going to select the first one, 0.0. It's important though also when mapping to a true analog device such as an Opto22 panel, you do need to specify the engineering units. The engineering units are the minimum and maximum allowable values you expect to see from the answer. In other terms, the minimum value is what gets mapped to the 4 milliamps, and the maximum value is what gets mapped to the 20, since it's a 4 to 20 analog system. So we're going to pretend, for purposes of this example, that this unscrambler model that we're running here produces a percentage. So the minimum value we would ever expect to see from this method would be 0%. So we're going to leave that as 0. And then we're also going to map this value here as 100%. So again, these engineering units have to be selected by somebody who understands what this model should be producing. And since we're pretending that this produces a percent, reasonable limits would be 0 to 100. So I have assigned the position, the point on that module, and the engineering units. I'll save these changes. So now we see this row has been updated. This is the current value that the method is producing, and you can see that that is being scaled to this number of milliamps. Let's play around with this a little bit. Let's say, this is producing a number around 4. Let's change this. Let's say that the minimum number that we ever expect to see from this method is 3%, and the maximum we would ever expect to see is 10%. So anything at or below 3 is considered out of range, and everything at or above 10 is out of range. So let's save those changes. I'll wait for a few seconds for this value to get written out again. So the value that the unscrambler model is producing is still 4.6, but notice that the scaled value is 7.6 milliamps. Let's lower this even a little bit more. Let's make this say 6. Save that. Now it's up to 12, and that's because 12 is about halfway between 4 to 20, and our number 4.6 is about halfway between 3 and 6. That's how you map an analog output from OmniView to an Opto22 device.